Today we're going to look at the exponents. I've given you two rules. We're actually going to come back to this rule next week. I don't think we have any problems on our paper today where we have to use this exponent rule here. But instead of using the rules, we're just going to use the definition of what an exponent is. What does it mean, x to the third power? What does that mean? And this is problem number 1. For some reason, I don't have my numbers up here. We don't even know what x to the third power means? And x squared means, and if you multiply them all together, you put it in exponent form, how many x's do you count? 1, 2, 3, 4, 5. And this is called expanded. I am going to expand it to figure out the answer. X to the 5th power divided by x squared. And then this one cancels and this one cancels. And what's left? 3 x's, otherwise known as x to the third power, not the number 3, but x to the third power. And so this is problem number 2. To expand it, 1, 2, 3, 4, and then multiplied by 1 more x. Then count them up. That's x to the 5th power. Pretty easy, isn't it? To expand this problem number 5, x to the 4th divided by x to the 4th. And then we cancel. And when you are canceling, you're dividing this x on top divided by this x on bottom. When you divide x divided by itself, how much is that? 1 times 1 times 1 times 1. It doesn't cancel out to 0. When you're canceling, you're dividing the number on top by the number on bottom, and when you divide something by itself, it's equal to 1. Now, how many x's are left, though? None, and that would be called 0, and that's why we have that rule at the top of our page. B to the 0 power is equal to 1. B stands for the base. Any base raised to the 0 power is equal to 1. If they don't see this kind of problem, most people think the base raised to the 0 power would be equal to 0. But the reason it's 0 x's is because they all canceled out, and when you cancel out, you're dividing it by itself. And so, next problem, we are going to expand to find the answer. 1, 2, 3, 1, 2, 3, 4, 5. That's all expanded out. This is x to the 3rd power. This is x to the 5 power. All together, I have 8 x's. Is this fairly easy? 1, 2, 3, 4, 5. X to the 5th power on top. X to the 4th power on bottom. All you got to do is cancel out the x's. How many are left? Just 1. We usually don't write x to the 1st power. I think I numbered this one incorrectly. This one was problem number 6. So then, on problem number 7, we have 2x squared times 3x to the 1st power. I don't know why it's x to the 1st power. Usually when we have x to the 1st power, we just leave off the 1st power. Now, these are all multiplied together. There's a property of multiplication called the commutative property that says the order doesn't matter. And so I can rearrange this so that my numbers are together and my x's are together. So you can see that 2 times 3 is 6 x to the third power. So when you have numbers, you just multiply the numbers and then you expand the variables. Problem number 8 has x to the fourth power divided by x to the sixth power. And then you cancel, and then what's left? But that x squared is in the denominator, isn't it? So what's in the numerator? Well, when you cancel this out, something divided by itself is 1, so this is 1 times 1 times 1 times 1. And my board is messing up. And that's 1 over x squared. You cannot leave out the 1 over x squared. Now, go back to a previous problem. Over here, you could write this x over 1, but when you divide by 1, 1 goes into x time. When you have a 1 in the denominator, you can leave it out. But you cannot leave out the 1 in the numerator. This is a problem like the one we did with the 4s. 1, 2, 3, 4, 5, 6, 7. Divided by 1, 2, 3, 4, 5, 6, 7. When you divide something by itself, it's equal to 1. When you divide something by itself, it's equal to 1, but it's also equal to x to the 0 powers, because after I canceled them all out, how many x's do I have left? None. And so anytime you have anything raised to the 0 power, that's equal to 1. Anything raised to the 0 power is equal to 1. Because that means all the y's got canceled out and there weren't any left. Anything raised to the 0 power is equal to 1. All the 2's got canceled out. Anything raised to the 0 power is equal to 1. All of that stuff is raised to the 0 power. So the answer is just 1. So what does this mean where you have a power raised to another power? So the third power means there are 3 of these. And then x squared, there's x squared, so now it's all completely expanded out. And how many x's do I have in all? X to the third power, oops. I'm expanding the 4. X to the third power, x to the third power, x to the third power. I wrote them down 4 times because of that 4 right there. X to the third power, another x to the third power, another x to the third power, another x to the third power. How many x's altogether? When you count them all up, there would be 12. Do you see why it's going to be helpful if you can figure out what the shortcuts are? If you had something like x to the 10th power raised to the 20th power, Would you want to expand all of that? So as you're doing your assignment today, please watch the patterns and see if you can figure out the shortcuts. This would be 2x squared times another 2x squared times another 2x squared times another 2x squared because of the 4 right there. So that's going to be 2x. I want to put all my 2's together. Those parentheses just mean everything's multiplied together. So I'm going to rearrange it. So my 2's are together. So what's this? What's 2 times 2 times 2 times 2? So this will be 16x to the 8th. This will be 3x to the 3rd power times another 3x to the 3rd power. You're going to multiply your numbers together. 3 times 3 is 9. 1, 2, 3, 4, 5, 6. So this is called expanding. We are expanding so that we can simplify. Expand first and then simplify. Now here we have x One, two, three. 1, 2, 3, 4. So cancel, 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 cancel. What's left? Now you're saying 2x. The correct mathematical way to say that is x squared, but that x squared is in the denominator. This one's in the denominator and that one's in the denominator. What's going to be in the numerator? This is the most often missed problem on the test. People forget to put the 1 in the numerator. Now, in order to save myself a little bit of writing, I'm going to simplify this part inside here first. And then I'm going to square it. So what's 10 divided by 5? And that 2 would be up there. And so cancel, cancel, cancel. And so what's left? So we have an x left in the denominator, and the 10 divided by 5 made a 2. So that is 2 over x times another 2 over x. We will be working on some fractions coming up pretty soon, but just let me remind you that for a fraction to multiply it, it's numerator times numerator and denominator times denominator. This is a 4, and this is an x squared. I simplified inside of here first just to save myself a little bit of writing. Hopefully, this will not be too terribly difficult.